Good day everyone, I'm Marjorie Sibiliones and today I am going to discuss our new topic which is perpetual calendar. But before anything else, let me ask you these questions. Do you know on what day you were born? Do you know on what day we will be celebrating Christmas of 2014? Can you predict the day when 2020 would officially start? There is a way for us to easily determine these days. Let's discover it with ourselves as we go on to our topic today. So these are the learning objectives. First is to understand the concept of perpetual calendar. Second is to understand the mathematical principles, history and evolution of perpetual calendar. And lastly is to understand the practical applications, limitations, and challenges of perpetual calendar. What is perpetual calendar? A perpetual calendar is a calendar valid for many years, usually designed to allow the calculation of the day of the week for a given date in the future. In this section, an interesting formula will be developed to determine the day of the week for any date in any year. But before accomplishing this goal, we must be given a hint of the history development of the perpetual calendar. Around 738 BC, Romulus, the legendary founder of Rome, is said to have introduced a calendar consisting of 10 months, comprising year of 304 days. His successor Numa is credited with adding 2 months to the calendar. Then Julius Caesar changed the Egyptian calendar, which was based on a year exactly 365 days, to a new calendar, the Julian calendar, with a year of average length of 365 and 1/4 days, with leap years every 4th year to better reflect the true length of the year. However, more recent calculations have shown that the true length of the year is approximately 365,2422 days. As the centuries passed, the discrepancies of 0.0078 days per year added up, so that by the year 1582, approximately 10 days had been added unnecessarily as leap years. To remedy this, in 1582, Pope Gregory set up a new calendar. First, 10 days were added to the date, so that October 5, 1582 became October 15, 1582. It was decided that leap years would be precisely the years divisible by 4, except divisible by 100. As an example, the years 1700, 1800, 1900, and 2100 are not leap years but 1600 and 2000 are. The Gregorian calendar now used throughout the world is so accurate that it differs to the true year by 0.003. In dealing with the calendar dates for various parts of the world, you must also consider the fact that the Gregorian calendar was not adopted everywhere in 1582. In Britain, it was adopted only in 1752, and by then it was necessary to add 11 days. Japan changed over 1873, Soviet Union and nearby countries in 1917, while Greece held out until 1923. These are the assigned numbers for the months and days of the week. 0 is equivalent for Sunday, 1 is Monday, 2 is Tuesday, 3 is Wednesday, 4 is Thursday, 5 is Friday, and 6 is Saturday. And for the months, March as the first month, April is the second, 3 is for May, 4 is June, 5 is July, 6 is August, 7 is September, 8 is October, 9 is November, 10 is December, 11 is January, and 12 is February. To find the day of the week of any date of any years in the Gregorian calendar, we could use this formula. D is congruent to R plus 2.6m minus 0.2 enclosed in a bracket minus 2c plus d plus c over 4 plus d over 4 modulo 7, where D is equal to day of the week, R is equal to given day of the given month, M is equal to the number code for the given month, March as the first month. C is equal to the first two digits of the year, and D is the last two digits of the year. For example, determine the day of the week on which January 13, 2019 falls. Since January is the 11th month of 2019, so RY is equal to 2019. Hence, RC is equal to 20, D is equal to 19, M is equal to 11, and RR is equal to 13. So using our formula, we just simply substitute all the given. So we have D is equal to 13 plus 2.6 times 11 minus 0.2 enclosed in the bracket minus 2 times 20 plus 19 plus 20 over 4 plus 19 over 4 modulo 7. So we have 13 plus 28 minus 40 plus 19 plus 5 plus 4 modulo 7. And that is equal to 29 modulo 7. And 29 modulo 7 is equal to 1 modulo 7. Therefore, January 13, 2019 falls on a Monday. So now, I will give you 3 minutes to try this problem. Determine the day of the week on which December 25, 2014 falls. So, since December is 10th month of 2014, so RY is equal to 2014. Hence, RC is equal to 20, D is equal to 14, M is equal to 10, and R is equal to 25. So using our formula, we just simply substitute all the given. So we have D is equal to 25 plus 2.6 times 10 minus 0.2 enclosed in the bracket minus 2 times 20 plus 14 plus 20 over 4 plus 14 over 4 modulo 7. So that is equal to 25 plus 25 minus 40 plus 14 plus 5 plus 3 modulo 7. And that is equal to 32 modulo 7. So 32 modulo 7 is equal to 4 modulo 7. Thus, Christmas of 2014 will be celebrated on a Thursday. So for your activity, try to answer these problems and send it to our Google Classroom. And that's the end of my discussion. Thank you and God bless.